A scientist in the International Space Station experiences weightlessness because there's no gravitational force from the Earth acting on her. So let's actually look at that statement first. Now, the ISS, or the International Space Station, rotates the Earth at a relatively close distance. I think it's around 200 miles above the surface of the Earth. So it might look something like this, and we know that in order for something to orbit a body in a circular fashion, so to engage in circular motion, there must be some centripetal force that provides a centripetal acceleration to constantly change the direction of motion of the orbiting object. And in this case, that centripetal force is the force of gravity from the Earth. So in this case, there actually is a gravitational force from the Earth acting on her, which causes her to have her orbital motion. Next, we have the gravitational pull of the moon has canceled the pull of the Earth on her. And this is definitely not true. So we know that the moon is much less massive than the Earth, and that the force of gravity is inversely proportional to the distance between masses squared. With that in mind, also keep in mind that the moon would be probably even further away than I've drawn it here if this diagram were to scale. And so the force of gravity of the moon acting on someone on the International Space Station would be almost negligible. And so it would definitely not be able to cancel the pull of the Earth on the astronaut. So that is not true. Next, we have at an orbit of 200 miles, so that seems to confirm what I said earlier, above the Earth, the gravitational force of the Earth on her is 2% less than on its surface. That may be roughly accurate. The gravitational force might be around 2% less. The point is that it's not very much less than it is on the surface. So why does the astronaut feel this sense of weightlessness? It's definitely not because of this very slightly reduced gravitational force, because it is not a whole lot less than the gravitational force that the astronaut feels on Earth, and nobody feels weightless on Earth. Next, we have in space, she has no mass. This is not true. Mass is quantity of matter, and that is independent of the position of the mass. Now, finally, we have she is in free fall along with the space station and its contents. And this is the answer that we're looking for. So if you imagine an elevator car and an elevator shaft in free fall plummeting straight down, if you were inside of that elevator car, you would feel weightless. Or maybe to give another example, if you're in a plane that's plummeting straight downwards, hopefully you've never had that experience and never will. I can't say that I have. You would feel weightless. So things would appear to hover in the air. Maybe you could float around inside. And that's the same thing that's happening on the International Space Station. That's why the astronauts feel weightless. Their apparent weight is zero because them and everything else around them is free falling. So nothing is able to provide a normal force against their free fall. So she is in free fall along with the space station and its contents is the answer that we're looking for.